Hello everyone, today's lesson we're going to learn how to perform all operations on functions, and I mean by 4 operations: addition, subtraction, multiplication, division. So to start the lesson, we need to recall how to simplify these 4 expressions. So I recommend that you give it a try, so pause the video and try to simplify these. Okay, I'm assuming that you already have paused the video and tried. So let's do them together. As you can see, the first one is addition, and I have a polynomial here and a polynomial there. So we're adding 2 polynomials. And what we need to do is to look for like terms. So x squared and here x squared. So I'm adding 1x squared plus positive 2x squared, and this is going to give me 3x squared. Similarly, for the next term, which is the term with x without with power 1, so negative 2x and here 5x. So I'm adding negative 2x plus positive 5x. So negative 2 plus 5 is going to give me positive 3x. And finally, positive 3 plus negative 7. So, positive 5 plus negative 7, so plus negative 7. So different signs we subtract, and the answer takes the sign of the bigger. So the bigger here is 7, which is negative, so the answer is negative 2. And this is the final answer for the sum of these 2 polynomials. Similarly here, you can easily open the second bracket, because with minus, everything change the sign comes after. So it will be plus 9x minus 2 minus 2x squared, and the first bracket remains the same, 6x squared plus 3x plus 4. So taking x squared together, so positive 6 minus 2 gives me positive 4x squared. Then 3x and 9x both are positive. 3 plus 9 equals 12x, and 4 negative 2. 4 minus 2 is positive 2. And here is the final answer of that expression, the simplest form of the difference between the 2 polynomials. Here I have 2 binomials. Between them nothing means a multiplication. So when I write them between brackets, it means I should multiply. So here let's recall the distributive property and the FOIL method. So multiply the first by the first, which will give me x squared. Multiply the first by last, and this will give me positive 2x. Multiply negative 4 by x gives me negative 4x, and finally negative 4 times positive 2 gives negative 8. Simplify. When I simplify, this is going to give me x squared. I have the middle 2 terms combined. Positive 2 minus 4 gives me negative 2x, and then minus 8. And this is the final answer for simplifying this expression, which is a product of 2 binomials. It could be a product of a binomial and trinomial, just a product of polynomials. The last one, it's a division. And the first thing to simplify a division between polynomials is to factor the numerator and the denominator fully, and then find if there is something that crosses out. So if I factor the numerator, it will give me x plus 2 times x plus 3. If I multiply 2 by 3, it will give me 6. If I add 2 and 3, it will give me positive 5. And in the denominator, it's already in the simplest form. I cannot factor further. X plus 2, you can see it will cross out, because the whole thing is in factored form with multiplication, and I end up with x plus 3. So x plus 3 is the simplest form. If I cannot find anything that crosses out like this, then I need to do long division, which is, this is going to be the dividend, and this is the divisor. Okay, now how this is related to our today's lesson, it is pretty much the same, because I'm going to give you here in this example 3 different functions: f of x, and then g of x, and then h of x. And then I will ask you to add f and g together, subtract f minus h, multiply f by h, and divide h by f. And then you need to do the simplest form and then try to find the domain of the final answer. So in the first question, f plus g, so x squared plus 4x plus g, which is square root x plus 2. So the first part here comes from f of x, and the second part comes from g of x. And if I try to simplify, combine like terms, I won't be able to do anything. So this is going to be the final answer, because no like terms, and I cannot combine anything under the square root with anything outside the square root. Now, if I want to find the domain of this function, I need to look at each part. So the domain of the polynomial is all real numbers, but the domain of the radical is different. It's restricted. So the domain of the entire function will be the domain of the common between them, which is the domain of the radical. And to recall the domain of radicals, we take anything under the radical, x plus 2 greater than or equal 0. Here I'm considering the equal, because the radical is not in the denominator. Solve this will be x greater than or equal negative 2. If you want to write it in interval notation, it will be negative 2, comma, positive infinity, closed at 2, open at infinity. F minus h. F is x squared minus 4x. H is this. So I need to be careful, because it's a minus. So I'm going to open a bracket, put h, which is 3x minus 5, and then close the bracket. Now here I will be able to simplify this expression because it's all polynomials and I have some like terms, but I need to be careful because this minus will change the signs for everything comes after. So it will become x squared minus 4x minus 3x plus 5, and eventually it is x squared minus 7x combined like terms plus 5. And this is the final form of the difference of the function f and h. Now, if I want to find the domain of this function, this is a polynomial function. So the domain of a polynomial function is all real numbers, whether I write r or I write negative infinity, comma, positive infinity, as we did before. Okay, the next part is when I multiply f times h. So if I multiply f, which is x squared plus 4x between brackets, and then h, which is 3x minus 5. So here is what, similar to the starter we did, I have two binomials I need to multiply. So I'm going to multiply first by first, first by last, second by first, second by last, and then write the answer. So it will be 3x cubed, because x squared times 3x is 3x cubed. Then x squared times negative 5 is negative 5x squared. 4x times 3x gives 12x squared. And then finally 4x times negative 5 gives negative 20x. Do I have any like terms? Yes, I do. Here 3x to the power 3 remains the same. Negative 5 plus 12 is plus positive 7x squared minus 20x. And this is again a polynomial, so the domain is going to be all real numbers. The last example here is to divide h by f. So h is 3x minus 5 in the top, where f is x squared plus 4x. And this is a rational function. And the domain of a rational function is all real numbers except the zeros of the denominator. So here the denominator is x squared plus 4x. If I set it not equal to 0, so I can find the values of x that I should exclude. Here I can solve it by factoring or using the calculator. So factor out x, that gives me x plus 4 equals 0. Take the first factor, x, set it equal to 0. The second factor, x plus 4, set it equal to 0. The first factor gives me the first value, x equals 0. And the second factor, when I solve it for x, it will give me x equal negative 4. So these two values, the 0 and the negative 4, if I replace them in this function, it will give me an undefined value. And therefore, the domain of this function will be all real numbers taking away negative 4 and 0, or except negative 4 and 0. I can write this as interval notation from negative infinity till negative 4. Open brackets, union from negative 4 till 0, open brackets again, union 0 to positive infinity, all open brackets. And this is the lesson about just apply or perform operations on functions, whether it is a sum, a difference. Here's a sum, here's a difference, here's a product, here's the quotient, or a sum means addition, a difference means subtraction, product means multiplication, and a quotient means division. And simplify using algebraic techniques. And finally, find the domain of the final answer or the result. Here are more practice for you. So again, as usual, pause the video, try, and then come back to check your solutions. Okay, so the solutions for this. So if I want to find f plus g is going to be x minus 4 plus square root of 9 minus x squared. And the domain for this will be the domain of the radical function. And you know how to find the domain of radical function, same as we did in previous lesson. F minus g is going to be x minus 4 minus square root 9 minus x squared. Here the square root is one term, so this negative does not change the signs inside the square root. And here I cannot simplify further, same like the first one, and therefore the domain will be the same, which is the domain of the square root. Now f times g, so x minus 4 times square root 9 minus x squared. Again, here the square root is not a binomial, although I have a binomial, two terms under the square root, but here we cannot apply the distributive property. It is not possible. So it's going to remain the same. And the domain of this function, again, will be the domain of the square root, because this part is a polynomial, and the domain of any polynomial is all real numbers. But since I have a square root is part of the answer, then I have to take the domain of the entire function as the domain of the square root. The last part, which is the division f of over g, or f divided by g. So f is x minus 4 over square root 9 minus x squared. And again, I cannot simplify. Here I have a radical that is under the denominator. So I'm going to do the same thing to find the domain, but without the equal sign. So for these three, the domain will be 9 minus x squared greater than or equal 0. And then I solve that. Here the domain will be 9 minus x squared greater than 0 without the equal sign. And then I solve that. The second example, here I have f is a polynomial function, g is also a radical function, so it will be pretty much the same. So f and then plus square root, f minus square root x. f times square root x, f divided by square root x. So pretty much will be the same. So I'm gonna leave this for you, and I will share the solutions to check your answers. More questions for you to practice as usual, and the last question is for critical thinking or reasoning to check your depth of knowledge. And here I'm giving you a difference, a subtraction of two functions. So I'm telling you that f minus g is equal to this, and I'm telling you that I'm telling you that g of x is this. The function g of x is x plus 4. So you need to figure out what is f of x. What is the function f of x that gives you this difference? And once you figure out f of x, then you can find f of 0.5 and f of negative 6 by just replacing x with these values. Similarly here, but here I'm giving you an addition or a sum. And also I'm giving you g of x as 2x. Then you need to figure out what is f of x, that if you add it with g of x, 2x, it will give you this answer. So figure out f of x, and then again evaluate f of 0.5 and f of negative 6. Good luck, and see you in another lesson.